So this is period, let's see, 2B, yes?
Yes.
Okay. 2B, group 1.
Right on.
Okay.
Okay, so our group studied ammonia contamination of well water in different proximities to rural areas. Let's do the clicker. We just, okay, right on. Okay, so our image, this is the one we chose, and it has clean water, no visible contamination, but could be possible contaminants at the chemical level, like ammonia, would be in the drinking water from wells. And the UN sustainability goal we chose was mainly number 6, which is clean water and sanitation, and number 3, which is good health and well-being, and number 12, which is responsible consumption and production. Okay, so introduction. Generally, runoff from feedlots and other concentrated animal feeding operations can contain high levels of ammonia. These levels of ammonia that are commonly found can cause organ damage with chronic exposure, like you would with drinking water. Then 1 milligram per liter over time is harmful, and there's generally a risk to health of humans and other living organisms, such as in the water or around it. And contaminated water can cause health to deplete with kidney failure and liver problems.
Brainstorming ideas. Ammonia is mainly used in fertilizers and from agricultural runoff from farmers watering plants. The ammonia from the fertilizer goes into like the streams, which goes into like wells. And then fertilizers use ammonia because it's nutrient dense and has a fast absorption rate, making like the plants like more healthy and grow faster. It's also cost effective because it's like high nutrients and it produces low greenhouse gases. And then the effects of ammonia cause irritation like on the face and on the body, rashing, gastrointestinal issues such as bleeding in the urea, lung damage, and neurological symptoms such as like seizures, strokes, or like dizziness. And then lethargy. So the problem defined, what are the effects of agricultural water runoff on ammonia contamination levels of well water in rural areas? And the test that we propose is that we will test 3 different 10 milliliter samples from 4 different water sources of different proximity to agricultural land. We will then test these sources for unhealthy ammonia levels and determine if increased distance leads to lower ammonia contamination levels in the drinking water.
Okay, so methodology overview. For the sample preparation, we're looking at amounts and levels of ammonia in different water sources with different proximity to rural areas. And then as a means of mitigation for dangerous levels and what classifies dangerous levels for human consumption. And then we're using ammonia test strips for the findings. We're taking 4 different water sources in test tubes. We're taking 3 samples from each source in order to make sure there's no like debris or anything in it. And basically inserting the strips into each test tube, then using those results for the classifications. And we're using distilled water and water that we know is 100% contaminated with ammonia as different tests. So for our data collection, we're recording the data from the test strips and from each water source and determining the dangerous levels and which sources have the most / least dangerous levels.
Okay, so moving into the materials for our test. So for safety first, we're looking at avoiding outside contaminations by keeping the experiment and testing location very secluded, so making sure that no outside sources of contamination can come in and cross with that. For personal equipment, that includes gloves and long pants and closed-toed shoes, again to avoid outside contamination. Make sure we're following proper lab safety and water collection procedures to avoid human contamination and like just general human error by wearing gloves. Then also making sure we're in a controlled temperature environment to avoid major changes or variations in room temperature of the testing location, as changes in temperature can have effects on the ammonia levels. Moving into the experiment equipment, we have 4 small test tubes, ammonia test strips for the 0 to 6.0 milligrams per liter, a graduated cylinder, a pipette, and lids for the test tubes. For the water sources, we're looking at distilled water as our control, and then we also have our like fully saturated ammonia water as another like form of control. We have 12 well water samples of 4 different proximities to the Treasure Valley, and then 3 samples taken at each well, and then again like the ammonia contaminated water as another control. Okay. Sorry. And then moving into like how we collect this water. So for the water collection, for each of the 4 water sources, collect as pure of samples as possible to avoid physical impurities like dirt or rocks. Using a clean 20 milliliter graduated cylinder and a clean pipette, wearing gloves, measure out 10 milliliters of each water source at the source. Pour that water into 15 milliliter test tubes, labeled respectively, like just based on where it's coming from, and lid them immediately after collection to avoid outside contamination going into the tube again. Repeating this process for each water source, one of which being still water and one of which being the ammonia contaminated one. Make sure we're cleaning the pipette and the graduated cylinder before each new collection. And then keeping these water samples in a controlled temperature environment and standing upright. Okay, and then testing the samples, we'll start with the distilled water, wearing gloves, remove the lid, and insert the padded side of the ammonia test strip. So the test strip just have like a padded side on there. You just insert that, make sure it's fully saturated, and leave it in there for 30 seconds. And then after that time has finished, remove this strip and then like just drench off the excess water and drip it off to the strip. And hold the strip with the padded side up for 30 seconds again. The strip will change color depending on the level of ammonia present, and then normally on the side of the test strip container, it has a key to look at, and dependent on the color, it'll tell you what the ammonia level is. And then using the color guide with the strips, note the shade and the corresponding ammonia level, and then record these results and repeat this for each sample and each water source.
All right. Now we got our hypothesis. We said based off our prior research, we predicted that the water sources from rural areas are more likely to contain ammonia, enough to cause harm to people's health. And this is most likely due to farmers using fertilizers on their crops and not containing the water from leaching to nearby water sources like well water, which ends up contaminating them. But for some negations that we came up with, where one is maybe to apply the fertilizers in like smaller doses rather than putting it all at once, which has a chance of like reducing the runoff and leaching to other sources. We're also thinking of like planting cover crops such as like clover, rye, or legumes to help, because those ones help absorb any excess nitrogen and reduce the ammonia from leaching. And then finally, we did implementing drainage water management systems, because that could help slow down the water, which allow the water, like the nitrogen in the water, to be absorbed before it enters any bigger body of